What you're about to see sounds fake, but it isn't. There's a woodworking technique so simple and so effective that professional builders have been using it for generations without ever mentioning it in a single YouTube tutorial or home improvement guide. It costs nothing, requires no specialized tools, and permanently seals cracks in wood using a substance you already have in your kitchen. The fact that this knowledge has remained virtually invisible in modern DIY culture tells you everything you need to know about what gets taught and what gets buried. If you like discovering things nobody talks about, hit subscribe. Walk into any hardware store and ask how to fix a crack in wood. They'll point you toward wood filler at $8 a tube, epoxy resin at $15, or specialized crack-filling compounds that run even higher. Every single one of those products is designed to be purchased repeatedly because they fail predictably. Wood filler shrinks as it dries, pulling away from the edges of the crack and creating new gaps that need more filler. Epoxy works until temperature swings cause the wood to expand and contract at a different rate than the resin, and the bond fractures. The entire product category exists because the solution they're selling you is engineered to be temporary. White vinegar and wood glue mixed in equal parts creates a bonding compound that penetrates deeper, flexes with the wood's natural movement, and hardens into a seal that becomes stronger than the surrounding grain. This isn't experimental. This isn't some internet hack that works in theory but fails in practice. This is chemistry that woodworkers have relied on since before the modern adhesive industry convinced everyone that fixing wood required buying proprietary compounds in branded packaging. Here's what happens at the molecular level and why it matters. Standard wood glue, polyvinyl acetate, is too thick to penetrate deep into a hairline crack. It sits on the surface, bonds the top layer, and leaves the deeper structure untouched. When pressure or moisture reaches that crack again, it opens right back up beneath the surface seal. Vinegar changes everything. Acetic acid, the active compound in vinegar, does two things simultaneously. It thins the glue, allowing it to flow into gaps and fissures that unmixed adhesive could never reach. And it slightly etches the wood fibers themselves, creating a rougher surface with more bonding sites for the glue to grab onto. The mixture doesn't just fill the crack. It saturates the damaged area, locks into the cellular structure of the wood, and as the water content evaporates, it leaves behind a bonded matrix that moves with the wood instead of against it. Temperature drops and the wood contracts. The bond contracts with it. Humidity rises and the grain swells. The repair swells proportionally. It's a dynamic seal, not a static plug. You can test this yourself in under an hour. Take a piece of scrap wood, any species, and create a split or crack. Fill one side with commercial wood filler. Fill the other with a 50-50 mix of white vinegar and standard wood glue. Let both dry completely, then stress the wood. Flex it, tap it with a hammer, leave it outside through a freeze-thaw cycle. The wood filler will crack, shrink, or pop out entirely. The vinegar glue repair will hold, and in many cases, the wood surrounding the repair will fail before the bond does. This raises an obvious question. If this technique works as well as decades of practical use suggest it does, why isn't it common knowledge? Why don't the tutorials mention it? Why don't the product manufacturers who spend millions on advertising ever compare their proprietary formulas to a mixture you can make for pocket change? The answer isn't that they don't know. The answer is that they know exactly how well it works, and a repair method that costs cents and lasts indefinitely is not a product you can build a business model around. The wood filler market alone is worth hundreds of millions annually. That revenue depends entirely on repeat purchases, and repeat purchases depend on products that solve the problem just well enough to seem legitimate, but not so well that the customer never comes back. There's a reason that traditional craftsmanship, the kind passed down through apprenticeships and hands-on training, often contains solutions that never appear in retail stores. It's the same reason that the most effective woodworking joints, the ones that have held structures together for centuries, require no fasteners, no glue, and no products at all. Knowledge that empowers people to solve problems without spending money has a tendency to stay quiet in an economy built on selling solutions. This vinegar glue mixture works on more than just cracks. It stabilizes split wood before it spreads further. It reinforces weakened joints in furniture that's starting to wobble. It seals checks in lumber that would otherwise require planing down to fresh wood. And it does all of this with materials that cost less together than a single tube of the branded alternative. But the technique only works if you know the correct ratio, the right application method, and the one critical mistake that will cause the entire repair to fail. Most people who try this for the first time make that mistake in the first 30 seconds, and it's not what you'd expect. The problem isn't the vinegar, and it's not the glue. It's what happens to the wood in the minutes before you even open the bottle. That's where this gets specific, and it's where understanding the actual science separates a repair that holds for decades from one that fails by next season. The wood has to be completely dry before the repair begins. Not surface dry, not air dry, bone dry, down to the depth of the crack itself. This is counterintuitive because most wood glues are designed to work on slightly moist wood. Standard PVA adhesives actually rely on a small amount of moisture in the wood fibers to activate the bonding process. But vinegar changes that equation entirely. When you introduce acetic acid to wood that still contains residual moisture, you're not creating a bond. You're creating a reaction zone where the acid breaks down surface linen faster than the glue can penetrate and cure. The result looks fine for the first few days, then it starts to soften, darken, and eventually the repair fails from the inside out. Professional restorers who work with antique furniture, people who stake their reputation on repairs that will outlast the original construction, follow a protocol that sounds excessive until you understand the chemistry. They isolate the damaged piece in a controlled environment with active airflow and low humidity for a minimum of 48 to 72 hours before applying anything to the wood. In some cases, they'll use a moisture meter to verify that the wood has dropped below 8% moisture content. That's drier than most kiln-dried lumber sold at retail. For someone working in a garage or basement without professional equipment, the practical version of this is simple. Take the damaged piece, bring it indoors to the driest room in the house, and leave it there for 3 full days minimum. Not near a heater, not in direct sunlight, just stable, dry air. If you're in a humid climate, a small fan running nearby will cut that time in half. The wood will feel lighter when it's ready. The surface will sound different when you tap it, sharper, less dampened. Those are the physical indicators that the internal moisture has equalized with the surrounding air. Once the wood is actually dry, the application method matters as much as the mixture itself. The instinct most people follow is to fill the crack from the outside, forcing the mixture in with a putty knife or brush until it looks full. That's backwards. The vinegar glue mixture needs to penetrate from the deepest point of the damage outward, saturating the wood fibers at the base of the crack before filling the visible gap. If you seal the surface first, you trap air pockets deeper in the wood, and those voids become failure points under stress. The technique that works is almost surgical. You need a syringe, the kind sold for gluing musical instruments or injecting marinade into meat. Load it with the 50-50 vinegar glue mixture and insert the tip as deep into the crack as the wood will allow. Inject slowly, letting the mixture wick into the surrounding fibers before you add more. You'll see the wood darken slightly as the liquid spreads. That darkening is the acid opening up the cellular structure and the glue following it in. Work from the deepest point toward the surface, withdrawing the syringe gradually as you go, never leaving a gap behind the needle. When the crack is fully saturated, that's when you clamp, not before. The pressure from the clamp should express a small amount of excess mixture from the seam. That overflow is proof that you've achieved full saturation. Wipe it away immediately with a damp cloth. Do not let it dry on the surface. Dried vinegar glue leaves a residue that interferes with any finish you apply later, and it's nearly impossible to sand off cleanly without affecting the surrounding wood. Clamping pressure needs to be firm but not extreme. The goal is to close the crack, not to crush the fibers around it. If you're seeing glue squeeze out along the entire length of the repair, your pressure is correct. If nothing comes out, you're not clamping hard enough. If the wood starts to deform or bow under the clamp, you've gone too far. Leave it clamped for a minimum of 24 hours. Longer is better. The acetic acid continues to condition the wood fibers even after the glue has set, and that process takes time. Some craftsmen leave structural repairs clamped for 72 hours, especially on hardwoods with dense grain structures like oak or maple. The patience pays off in bond strength that exceeds the wood's original integrity. There's a variant of this technique used for end grain repairs, the kind of damage that happens when a table leg splits vertically or a chair rail cracks along its length. End grain is notoriously difficult to glue because the open cellular structure of the wood wicks adhesive away from the bonding surface faster than it can cure. The vinegar solves this by collapsing those cells slightly, reducing their absorption rate, and giving the glue time to set before it disappears into the wood. The mixture ratio for end grain shifts to 60% vinegar, 40% glue. The higher acid content compensates for the increased porosity. The repairs that fail, the ones that seem to work for a few weeks and then come apart, almost always trace back to one of three errors. The wood wasn't dry, the crack wasn't filled from the bottom up, or the clamp pressure was inconsistent, leaving voids that weaken the bond. None of these mistakes are obvious when you're making them. They only become visible later when the repair's already failing and it's too late to correct the process. What most people don't realize is that this same mixture, applied correctly, doesn't just repair wood. It fundamentally alters how the damaged area responds to future stress. The acid-treated fibers become slightly more flexible, the glue penetration creates a composite zone that's stronger than either material alone, and the bond itself develops a kind of mechanical memory that resists the exact type of failure that caused the original damage. That's not marketing language, that's measurable. Engineers at the University of Massachusetts tested vinegar-treated wood joints under cyclical loading, the kind of repetitive stress that simulates years of use in furniture or structural applications. The treated joints outperformed conventional PVA bonds by 18% in fatigue resistance. They didn't just hold longer, they failed differently, fracturing through the surrounding wood rather than along the glue line itself. That shift in failure mode tells you everything about what's happening at the molecular level. Now, the part nobody talks about because it doesn't fit neatly into a weekend project tutorial. This technique has limits, and those limits are absolute. You cannot repair wood that has rotted. You cannot restore structural integrity to timber that has been compromised by moisture damage, insect infestation, or fungal decay. The vinegar will penetrate, the glue will set, and 6 months later the repair will collapse because the wood itself no longer has the cellular structure to hold anything together. If you're looking at gray, powdery wood, if the grain crumbles when you press it with your thumbnail, if there's any softness or sponginess to the material, stop. You're not repairing wood at that point. You're trying to glue dust, and no amount of vinegar is going to change the outcome. The second limitation is environmental. This repair method depends on the wood remaining dimensionally stable after treatment. If you repair a crack in a piece of outdoor furniture and then leave it exposed to rain, freeze-thaw cycles, and direct sunlight, the wood will expand and contract at rates the glue bond cannot accommodate. The repair will hold through the first winter. It might hold through the second. By the third year, you'll be starting over. Vinegar glue repairs belong indoors in climate-controlled environments on furniture and structures that aren't subject to extreme moisture fluctuations. Trying to use this on a fence post or a deck railing is a waste of time and materials. There's a historical angle here that most contemporary woodworkers have never encountered because it predates the modern adhesive industry by several centuries. Cabinet makers in 18th century France used diluted acetic acid as a wood conditioner before applying hide glue to veneer work. They didn't call it a repair technique. They called it preparation. The acid opened the grain just enough to allow the hide glue to penetrate deeper than it would on untreated wood, creating bonds that held through humidity changes that would have delaminated conventional work within months. Some of those veneered panels are still intact in museums across Europe. The glue didn't survive because it was superior. It survived because the wood was prepared correctly. That same principle applies to modern repairs, but the materials have shifted. Hide glue has been replaced by PVA and polyurethane formulations that cure faster and tolerate mishandling better. Acetic acid concentrations have been standardized through white vinegar, which removes the guesswork from dilution ratios. The chemistry hasn't changed. The accessibility has. What happens when you scale this up? Not to furniture repair, but to structural timber in older homes where floor joists have developed stress cracks or support beams have split along the grain. The process adapts, but the execution becomes significantly more demanding. You're no longer working with a table leg you can clamp on a workbench. You're working with lumber that's load-bearing, often in place, sometimes overhead. The mixture ratio stays the same, but the delivery method shifts. Instead of a syringe, you're using a pump sprayer to saturate the crack from multiple angles. Instead of bar clamps, you're using hydraulic jacks to close the gap while the glue sets, then installing mechanical fasteners, bolts, or lag screws to maintain pressure after the jacks are removed. The vinegar still does its job, the glue still penetrates, but the margin for error shrinks considerably when the wood you're repairing is holding up a floor. One more thing that separates successful repairs from the ones that quietly fail over time. Temperature matters. White glue cures through water evaporation, and that evaporation rate is directly tied to ambient temperature. In a room below 60 degrees Fahrenheit, the glue will take twice as long to reach full strength. In a humid basement, longer still. If you're repairing a piece of furniture in your garage in February, you're not just fighting the cold, you're fighting the physics of how adhesives set. The vinegar doesn't care about temperature. The acetic acid will penetrate wood at any reasonable working temperature. But the glue does care, and if you unclamp the repair too early because you didn't account for the slower cure time, the bond won't hold. This isn't advanced carpentry, it's basic chemistry applied with patience. The vinegar opens the door, the glue walks through it. The clamp keeps everything still while the bond forms. Miss any one of those steps, rush any part of the sequence, and you'll end up with a repair that looks fine until someone leans on it. The craftsmen who figured this out decades ago didn't have access to epoxy resins or cyanoacrylate adhesives. They had white glue, vinegar, and the understanding that wood isn't a static material. It moves, it absorbs, it responds to its environment. The repairs that last are the ones that work with those properties instead of against them. You don't force wood back together, you condition it, saturate it, and give it time to remember what it was before it cracked. That's the difference between a fix and a restoration. One hides the damage, the other reverses it. The wood doesn't forget the stress that broke it, but with the right preparation, it stops failing at the same point. That's measurable, that's repeatable, and that's why it works. A repair technique this effective, this inexpensive, and this proven doesn't stay hidden by accident. It stays hidden because there's no profit margin in teaching people to solve problems permanently with materials they already own. The vinegar is in your pantry. The glue is in your drawer. The knowledge is right here. What you do with it determines whether the next crack in your furniture becomes a weekend project or a reason to buy something you didn't need.